Dear all, first of all, thank you so much for joining and welcome to today's railway webinar, Cross-Sector Fertilization will deliver faster digitalization. I am Virginie Toussaint and I will act as the moderator for today's session. In today's webinar, our expert panel of leaders from the rail industry, together with Capgemini specialists and Network Rail, will share their insights on how digitization will support overcoming new challenges, focusing on cross-sector technologies use and how it is a revolution for railway signaling. Our speakers today are Andrew Hawthorne, Integrity Systems Chief Solution Architect at Capgemini Engineering, Johan Lon, Innovation Consultant at Capgemini, and Carl Butler-Garnan, Interim Chief Intelligent Infrastructure Engineer at Network Rail. Before we begin, I would like to cover a few important points. If you have any questions during the session, you can send in the Q&A console and submit them for our speakers. And the webinar recording and presentation will be, of course, available afterwards on our website. So for today, on the agenda, we will introduce the topic, give to you a global presentation of the topic, of course, and discuss all together with our experts on the transformational technologies. And we will let you the opportunity at the end of this session to answer some questions during our live Q&A session. With that, I invite Andrew Hawthorne from Capgemini Engineering to start the session. Andrew, the floor is yours.
Thank you, Virginie. What we're seeing across all of the different industries that we're working with is a number of trends where we're seeing increasing connectedness of the different parts of the systems. The subsystems are talking to one another far more. We're seeing far more advanced functionality as our clients, our customers, people like you and I demand ever more functionality. And we're seeing a need to get these products to the market much more rapidly. As consumers, we all expect our mobile phones to be all singing and all dancing and updated as frequently as daily or weekly. And increasingly in the operational systems world, where we're talking about trains, planes and cars, consumers are expecting to see that level of rapid change in those systems as well. And what today's talk is about is how the railway industry can learn lessons from the other industries that we're working in to help them digitize faster. So the railway industry is under a great pressure for digitization. There's two key areas really. One is a need to increase the number of trains that are running, both for passengers, so the business market, the leisure market, but also for freight. You know, from a sustainability angle, we want to get freight off the roads, off the trucks, and onto the railway network. We also see that maintaining the railways is exceedingly expensive. There is a lot of infrastructure on the track side that needs to be maintained. And if we can remove the need for that trackside infrastructure using digital systems, where we're talking about electronics and software taking control, then we can reduce the cost of maintaining the railways whilst adding advanced capacity, higher capacity for both those freight and business and leisure usage as well. And so our vision of what the future railway signalling system looks like is given on this diagram here. There's all sorts of changes that are going to take place over the next decade. So I'll just touch on some of these. I won't go through all of these points. So from a train signalling perspective, so we have signallers sitting in signal boxes or regional operating centres, and they generally, for when the trains are running to the timetable, they don't need to do too much, because we have automatic route setting systems that will automatically set the interlockings, set the signals, so that the trains just run with little human input from the signaller. But as soon as the timetable gets perturbed, which, as we all know, is quite regularly, then the signaller needs to step in and identify the best way of getting the trains back to running against the timetable. And sometimes that may be fairly straightforward. So if your train is delayed by a few minutes because there's so many passengers trying to get on or off, then it might be that the driver can just drive a bit faster than they had planned. But in other cases where there's a failure of a signalling system, then finding out the best way of getting trains back on timetable is very complicated. And this is where AI could help. There's going to be a big change with the way in which all of these systems connect together and communicate to one another, with a jump from GSMR, which is the rail equivalent of 2G wireless connectivity, to FRMCS 5G. And we'll talk more about that later. Another area that we need to consider is infrastructure digitization. This is about having a digital map, as it were, of all of the railway infrastructure. So particularly the tracks. If we're going to be able to control electronically, digitally, remotely our trains, we need to know precisely where things like the track and the track infrastructure is. And that's where infrastructure digitization comes on. And using technologies like drone and AI image recognitions will help that. Cloud computing is another area which we'll talk about later. That has the ability to take all of these different electronic systems and put them closer together so they can work better together. One of the key things that European operators are working together on is the rollout of something called ETCS, which is the European Train Control System, which is going to, amongst other things, remove line-side signals and replace them with in-cab signals. Now, the rollout of ETCS is going to take many decades because it's a very big and complicated system, and we have many tens of thousands of railway to upgrade, and that's just in the UK. If you look across all of Europe, then we're talking about hundreds of thousands of kilometres of railway that would need to be upgraded. So a number of the network operators, like Network Rail, are looking into ways in which we can take some of these ideas from ETCS and apply them in a lighter weight fashion. And as I said earlier, we need to get these products to market much more quickly. And so we're seeing the increased use of simulators and digital twins to left shift verification and validation. That is, if we can do the testing in a virtual environment, and we can demonstrate that all of these systems are fully integrated and working together in a virtual environment, then that allows us to much more rapidly upgrade these systems and release them and roll them out to the network with less on-site testing, which will again enable faster rollout. So underpinning all of these changes are a number of key enabling technologies, and we're just going to focus on three of them today. AI, artificial intelligence, also known as machine learning, cloud infrastructure, and 5G, which you all have heard of through your mobile phones. So I'm going to start off by talking about artificial intelligence. So within the railway industry, there's a number of different areas where artificial intelligence can help. But I'm just going to focus my discussion today, and we'll open this up a little bit later, around autonomous driving of trains. Now, automatic train operation is in use at the moment. There's various grades of automation, as you'll see in the bottom right-hand corner of the screen. And the amount of automation increases as the environment in which the train is operating becomes more and more constrained. So within metro systems, on underground trains, it's quite a constrained environment. particularly on new lines like the Elizabeth line, where there are doors on the platform. There's no way that humans or animals can get up onto the line. So it's a very constrained environment. And so we can automatically drive those trains. And indeed, the plan is to automatically drive the Elizabeth line trains. But when you move to what we call mainline railway, which is the trains that move from city to city, the environment is much less constrained. There's much more that can happen. For a start, you've got weather taking its course, so things like leaves on the line can affect adhesion and therefore your braking distances. But the driver also needs to keep an eye out for things like obstacles on the line, be they people or animals or things that vandals have left, and other things like landslip. So in order to fully automate trains, we would need to have some kind of electronic system that takes on those responsibilities. And that is where the railway industry can potentially look to the automotive industry. So in the automotive industry, there's a lot of talk about autonomous vehicles, and most of the motor manufacturers are investing heavily in autonomous vehicles. That they want to get to the point where drivers can relax and go to sleep or watch a movie on the entertainment system. So the automotive industry has been looking at technologies like LiDAR, radar, microphone and image recognition, and combining that with AI to build up an accurate picture of the environment, so that the vehicles, the cars can be controlled completely autonomously. So can we just take that technology from the automotive industry and put it onto a train? Well, unfortunately, or some people might say, fortunately, not. There's a lot of things that we need to do before we can put these kind of technologies onto a train. We need to get them certified, and certification requires us to really consider all of the ways in which the systems that we develop could go wrong. And then we need to identify ways in which we can mitigate those issues so that we can keep the passengers safe at all times. Now, there is lots of research going on around the use of these technologies like LiDAR and radar, but also specifically AI, to make it so that we can get to close, so that we can get towards a point where we might be able to certify. So for AI, for example, we're doing research with MIT in America on assurable AI systems. So how can we understand what that AI is doing sufficiently such that we can be confident that it's always going to do the right thing? So there's lots of opportunity here, but quite a few challenges as well. So Johan, over to you.
Perfect, thank you, Andrew. Really interesting as well to hear about some of these use cases and how what's happening in automotive could be applied to the rail industry and vice versa as well. I think this would be a great time to bring in Carl from Network Rail to understand a bit more. What's Network Rail doing in this area? What are some of the exciting opportunities you're seeing and starting to explore?
Thanks, Johan. Thank you, Andrew, for the presentation. We're doing a few different things in this area. If I can focus first on ATO, which is what you've got on the screen there. We have, as part of our research and development portfolio for this control period, a large program of activity looking at addressing the sustainability challenge with regards to signalling. And within that is a specific project looking at ATO and the strategy for ATO for the GB Railway. We have taken the decision at this moment to complete the project up to and including GOA2, so Grade of Automation 2, which you can see on the screen there. And we've done that for a number of reasons. One is that going up to 3 and 4 requires quite a lot more development from our side, quite a lot more investment at this stage. I think we feel as well that we can get quite a lot of business and operational benefits from GOA 2. That's not to say you wouldn't get benefits from 3 and 4, but the trade-off in going from 2 to 4 versus the level of disruption and challenge with regards to things like industrial relations, because let's be honest, essentially if we go from 2 to 4, you are essentially removing people from the train. And in the environment we're in the UK, as everyone can probably attest to, that's quite a challenge to get those types of changes through. So our focus is very much going to GOA 2. That said, we are involved with the Shift to Rail program in Europe, which are also looking at ATO technologies and going up to 3 and 4. We're taking the view of monitoring what's happening in that space, with a view to ensuring that anything that is developed across that program, it has some applications for GB Rail in the future, so that we're not totally out of the loop. So that's regarding the ATO side of it. In terms of the other side of artificial intelligence, and those of you that follow Network Rail on places like Facebook and social media will see we have some videos that we regularly show on how we're utilizing image recognition technology and that side of AI. So there was one I saw last week, which was we're using forward-facing video on some of our infrastructure fleet, and we're applying AI technologies to that to identify graffiti on the network and new items of graffiti. That's not for us to collect images of graffiti, that's for us to identify trespassing hotspots. So we can have a look and see where we believe trespassing is happening. That will help us improve performance and reduce the danger to trespassers coming onto the network, particularly during live operations of trains, etc. So there's a couple of different ways there which we are in NR looking at deploying AI type technologies.
No, great. Thank you, Carl. Some really interesting things there. And I think what's really interesting is you're talking about multiple use cases of AI. It's not just one thing, such as the self-driving trains of the future, but it's also smaller things you can do in kind of the day-to-day operations, be that around the stations, around the network, or wherever it is. How are you feeling it works in terms of adoption? The self-driving train still feels a few years away in my mind, but do feel free to challenge me. But how are you feeling the adoption's going in some of these other use cases? Are people excited to do it, or what are some of the challenges and maybe getting everyone bought into it?
I mean, obviously currently we've got the ongoing disputes in the UK around not just paying conditions, but the modernisation of the railway. And part of that modernisation journey is the use and deployment of new technology to support current business processes or improve them. I think where you've got something fundamental, like ATO has the prospect, as I say, of fundamentally removing a job role from a train, i.e. that of a driver or an attendant on board. Those sorts of levels of changes are going to be met with significant challenges. Where you've got technologies such as image recognition or, for example, like our security and analytics tools that we use to monitor stations, in those situations, the tools are there to support existing roles. And in those types of deployments, there's always a human in the loop, either to validate or check. So those sorts of challenges are much more simpler to overcome. So there's still challenges because it's still challenges to business processes, and we have to consult properly on those. But where the technology is used to support someone doing an existing role more effectively, we often find that the path to deployment is often easier. It still requires consultation. We still have to make sure that the business change is right, that people are trained, etc., and that they have the capabilities to use that new technology. But they are a bit easier when they're not so fundamental as what you would find ATO is.
No, definitely. As I think you make some really interesting points there about, and it's also about upskilling the people, isn't it? Getting more out of your staff, creating more time for them to actually focus on those key activities, and not necessarily replacing jobs in many of these cases, but kind of working hand in hand with AI to deliver even more value to the network and to the passengers at the end of the day.
Yeah.
We bring Andrew back in. I'd be really keen to see, what have you seen in other industries? You spoke a bit about automotive already, but what might be some of the other really interesting AI use cases that you think could be really relevant in the rail industry, be that from a operation perspective, more kind of the station, or even from a passenger experience perspective?
So there's so many different options there. So we're seeing AI being used in systems that identify passenger flows through railway stations and assessing the number of passengers in each compartment, so that we can provide to passengers through an app an indication of which trains they should aim to get. Should they get the very next one, or should they wait half an hour and be confirmed to have a seat. We're also seeing AI being used to help maintenance. All sorts of different cases where AI can help on the maintenance side. We've got a project where we're trying to assess the level of vegetation alongside the tracks, and using AI to identify what types of plants there are, so that we know how quickly they're going to grow and can plan maintenance of keeping those clear. But also of the equipment, making sure that the point systems are always going to open and close. There's been lots of what we call remote condition monitoring systems around for a while on those. If we can start to apply AI technology to kind of learn the failure cases of different types of point systems, then we can again more effectively maintain those systems. So getting the maintainers out at the point when the systems need maintenance, rather than having periodic maintenance, would reduce the number of trackside visits and therefore reduce the risk to maintenance personnel. So there's a whole host of use cases.
No, great. It is clear there's just so many opportunity areas, and it's finding those kind of key ones that will add the biggest value, isn't it? Carl, I'm going to ask you one more question before we move into the next section. Is what industries do you look at outside of rail for inspiration, and what really excites you that you think we need to bring this into the rail industry?
So I think yeah, it's interesting. We have various different relationships with a lot of different industries. We, as part of our R&D portfolio, we have what's known as an industry advisory board. So we take often some of our challenges there to them, and that's got representation from various different industries like oil and gas, automotive, highways, aviation. So essentially, we kind of kick the tires on our ideas, but also look at that as a forum to understand what they do in that space. Picking up on Andrew's point about LiDAR, we do use an awful lot of image recognition. And as I say, the obstacle detection stuff, that is, I think that has been tried and tested in automotive. And that's what we're kind of utilizing that from. Taking some of that positional and imagery information from the automotive sector and applying it to user cases that we have on the railway.
Oh, great. Cool. No, thank you very much. We're going to hand back over to Andrew again. He's going to take us through the next technology, 5G, and then we'll come back and have a bit more of a discussion around that.
Thank you, Johan. Okay, so 5G technology is going to be, I think, a real game changer for the rail industry. Taking the technologies that the telecommunications industry have really made huge differences to the technology over the years. So at the moment in the railway industry, they use technology called GSMR, which is based on 2G technology. So if you were one of those first movers to buy a smartphone back in the early 2000s, it was probably running on 2G, and it probably took several minutes to load up a basic HTML page. Fast forward to today, where we're using 5G, and the communications technology is so quick that you can live stream video, high quality video, and all sorts of things. Now, the railway industry is going to make the leap from 2G to 5G in one go, effectively. So all of the systems that we've been talking about, so the signalling system components, the points, the level crossings, the interlockings, the trains, the train control systems, where they're using wireless systems. At the moment, they're using GSMR and 2G for data. Changing that to 5G is going to open up so many possibilities with respect to functionality that can be built on top of that. So, when you've got far more data bandwidth, reliable communications that you can use for safety-related applications and low latency, then you can use that technology for train control, for train position information, and a whole host of things that some people probably haven't even thought about yet. So 5G is going to make a really big difference. Big difference. But there's numerous challenges to the railway industry moving to 5G. At the moment, we have literally just in the UK tens of thousands of devices based around the GSMR standard 2G. So every single train, of which there's well over 10,000, has a 2G GSMR cab radio in it. Just upgrading those cab radios to 5G would be one difficult problem. But if you also but in order to roll out ETCS and these digital signaling systems, we need to upgrade all the trackside systems as well. So there's literally tens of thousands of systems that need to be upgraded. And of course, you can't do that overnight. You need to do that in a kind of incremental fashion. You need to roll it out steadily. So we need to have an FRMCS 5G rollout strategy that expects it to take probably at least a decade, maybe 2 decades to roll out 5G. But the network operators are really keen to get used to this technology as early as possible. So what they're looking at doing is creating a stepping stone with public cellular networks instead of moving directly to the FRMCS standard. So those stepping stones will enable specific solutions to be built. And then when the FRMCS standard is issued, which won't be until 2025, and then the infrastructure upgraded to support it, then we can have more standardized solutions. So I know that there is a lot of communication going between the infrastructure owners, but at the moment, they are each developing their own rollout strategies, and until that standardization happens, we won't see a kind of mass rollout of these systems. It will just be for 1 or 2 use cases. But the future is looking really positive, and as an engineer, I'm really excited by the possibilities that the several orders of magnitude greater bandwidth that 5G will give us will open up. Back to you, Johan.
Thank you, Andrew. Again, really interesting to hear about 5G and how you see it really transforming the industry. It's definitely something we've been hearing people talk about for quite a while now. I probably remember the changes between 3G, 4G, and now 5G coming along, and some of the opportunities we're seeing just as individuals in our private life, and some things that are just changing of how we live day to day. I'm going to ask the same question again, Carl, back to you what I asked the last time. What's Network Rail doing in this area, and what are some of the exciting opportunities you're seeing?
Thanks, yeah. So I think obviously Network Rail has its own telecoms department, so I'm sure that they're doing an awful lot of work in this space as well. But in terms of specifically 5G and FRMCS, We have actually had a piece of work been ongoing with yourselves, Capgemini Engineering, looking at how we prepare for FRMCS rollout from late 25 into the next few decades. And it's clear what's coming through that piece of work is that there needs to be a communications backbone for the deployment of electronic signaling. So ETCS, like Andrew mentioned at the beginning of this webinar, relies on having signaling information shared between the signal box and the train itself through the air. So that has that communications backbone, and it's clear that GSMR is not able to cope with the data transfers and the latency required for that type of safety system to keep trains apart. So FRMCS is essential to support the journey towards ETCS rollout and sustainable signaling in general, which is why it's a core part of our future command control and signaling strategy to look at and establish how we build upon FRMCS.
Oh, great. Yeah, no, really interesting. I think you make some good points there. What's required and some of the challenges we're facing today. And I think that goes back to one of the points Andrew was making about this kind of two-speed approach. You know, we're deploying it, but we're also having to deliver the current service at the same time. We can't just switch overnight, can we? Which is a challenge. You know, the UK is a complex nation as well, or a collection of nations. We have different coverages in different places. Are you seeing some of that across, you know, is it the technology more adaptable in certain places? Is, you know, the remote highlands proving more challenging? Or is this a great opportunity to maybe leapfrog the remote highlands to really put this technology in, whereas, you know, the busier areas might actually be behind in some ways because they're still having to use some of the older systems?
It very much depends on the user case for the basis of the technology. So if you're looking at 5G FRMCS networks to support applications for asset monitoring, essentially where you've got a point data logger or a piece of equipment monitoring either set of points or piece of infrastructure, and that needs to communicate with a central cloud-based system, which we'll come on to in a bit. Then yeah, then there is an opportunity there to accelerate and roll out things for that. If you are looking at something on the more larger scale of ETCS rollout, there are a number of other dependencies upon enabling that type of system that are outside of just the communication backbone. So I'm thinking here about, you know, the fitment of equipment onto the train itself, the systems in the back end that sit within those signaling regional operating centers to facilitate ETCS. That's why we have a very large program activity on our East Coast region looking at how we roll out this type of technology, because it's not just about the comms, it's about everything else that goes with it. And that's why Andrew's right. When you look at the current timeframes for rollout of those types of technologies, they are measured in years rather than months, because there's so many moving parts that need to be brought together. And the 5G comms is one element of them. So I think, in answer to your question, you know, there's advantages to be had, but it very much depends on the user case for the tech.
Oh, can I ask, there's the 5G standard allows effectively public cellular communications to be shared with critical industry communications. So is there an opportunity for Network Rail to work with the cellular network providers in the UK, like 3G and EE and O2 and all that lot, to work together to roll out this technology?
It's possibly an opportunity. I think one of the things to overcome is that obviously GSMR is a specific rail application of GSM. So, yes. So historically, there's this sort of demarcation between GSM for public and GSMR for rail operational use. At this stage, I don't know, and it may even be in your report that's currently going to review with us at the moment in terms of recommendations for that. I don't personally know whether that sort of rationale would be carried forward. I very much would expect that it would be within our network rail telecom community and our professional head of telecoms that would be looking at that. The other thing, I guess, reflecting upon that is the considerations around increased security and cyber security for those types of systems, particularly the way the world is going at the moment. So there would be lots of things I think that they would need to consider to make that form of decision. And I don't doubt it may involve government, given that the railway is an important strategic asset for the country.
Yes. Yep. Thanks.
No, excellent. I just want to pick up on one more part. One of the things 5G is a great enabler of is data. We're going to have more data. There's going to be data everywhere. But is that also a challenge? You know, and I'm going to ask this to both of you, but maybe I'll start with you, Carl. Do you think it's going to be a challenge for Network Rail to have all this data, know what to do with it?
The answer to your question, yes, yes, it will be. I think for an industry that has been around for 200 years and has the sort of working practices, it's a challenge to change mindsets to rely upon data and trust data. I think it's a challenge. You know, if you say you want to go and monitor every set of points across the country and etc., then the volumes of data are huge. We have in the past, you know, looked into unattended measurement systems on service trains to monitor our infrastructure. The volumes of data in that are incredible. And so I think this is kind of the link for this webinar between, you know, you've got this comms backbone here, and I know we're going to go on to the cloud computing in a bit, but that is where you really do have to rely on AI to pick up a lot of the back end work. So in a Nirvana situation, you'd have edge computing. So actually what you'd send back to the center would be the things you need to action rather than where we are currently, which is sending back everything. So I think that's probably one of the biggest challenges, is how do you sift out what it is you need to know versus everything that is coming back?
Definitely. It's easy to get almost data tired otherwise, or drowning in data.
Yes, we're data rich and information poor, I guess would be the way I'd probably put it.
No, definitely. Andrew, what about you?
Yeah, I think there's so many different issues around all of this data that's going to be produced. You know, one of which is effectively IP. You know, so if you're collecting data from all of your systems that are out there and bringing them into a central place, and then getting a third party to analyze that data to find faults, then potentially you're sharing IP from all of your suppliers of those systems with another person, and those suppliers might not actually be happy for that data to be shared. So there's a big issue there. The volume of the data, I think, is a really interesting one. We do have solutions to handling vast quantities of data and analysing vast quantities of data. But as Carl said, if you can minimise the data that is shared, so you've got this edge computing doing the local analysis, that's great. But there's always a balance to be played, because if you can share more data, you can compare different let's say point systems across all of the UK at a very fine level of detail. Whereas if you only share the actionable information, then you may not pick up on similarities. So for example, I don't know, it might be that 1 in 10 point systems that consume above, I don't know, a random number of amps is likely to fail in 5 years, and 1 in 20 is likely to fail in 3 years or something. And it's only when you aggregate that data and start looking for those patterns using technology like AI that you can spot those those similarities. So it is really difficult. Just managing all this data is going to be a big challenge. And you know, in the railway industry, data has always had a particular level of importance, because particularly for things like interlocking systems, the data within them is absolutely critical. You've got to have that data right. So I think the railway industry is good at managing critical data, small amounts of critical data. Managing these large quantities of data that you're not sure exactly how you're going to use it, that's going to be a real challenge.
Sounds like data scientists are going to be in high demand going forward as well. Great.
Absolutely.
I think this is probably a good time to move on to next kind of topic area of cloud, where potentially all this data is going to be hosted.
Absolutely, absolutely. So cloud computing can help, as you say, manage this data, but bring these operational systems together. At the moment, the operational technology data centers, so the data centers that contain the servers and computers that control our trains and the points and the signaling system, they are using, in my view, more and more out-of-date technology. So the physical hardware, you know, the servers that we buy for the operational data centers, probably exactly the same as the servers that we buy for the IT systems. But the software that's running on that, the software that's managing redundancy and failover solutions and backups and things like that, is becoming more and more out of date, because the IT world is making so quick advances, and the IT world is investing heavily in the cloud. Everything is moving into the cloud. So there'll become a point in probably not too distant future, probably 10 years away, where it becomes more and more difficult to maintain your own data centers for operational technology. So at some point, the railway industry needs to move towards this technology, and there will be many benefits from that. And obviously, the IT industry is where we want to look for these technologies. But there's a number of challenges to overcome. So the current cloud solutions out there are really good. They allow you to just buy an hour of processing time or thousands of hours of processing time, and you don't need to worry about the hardware that's running it, the software, the operating systems. You don't need to worry about all of those things. But from a safety perspective, from an operational technology perspective, you actually do need to understand, or you need to understand aspects of what is being done by what, so that you can be confident that it is safe. So how we can, so coming up with a safe and secure cloud architecture is a challenge, and certifying it is a challenge. We've got some great technologies from different industries where we've been developing secure cloud. There's a lot of overlap between a safe cloud and a secure cloud, but there are some differences as well. So what we're looking at doing is building on those secure cloud technologies to make a safe and secure cloud. Another challenge that the industry would need to overcome is to migrate towards that cloud. How do we do that? Previously, we've had literally a physical wall separating IT and OT servers. If we start merging them, that's going to create all sorts of organizational difficulties, but also there's a lot of work to be done to migrate existing systems into the cloud. So how would we do it? Would we only migrate? Would we only put new systems into the cloud? If that's the case, then it's going to take many decades before everything is in the cloud. And that's when you start to get real benefit, is when everything is in the cloud, sharing data, working together, and allowing rapid updates of these technologies. Over to you, Johan.
No, perfect. Thank you, Andrew. I think yeah, the possibilities the cloud offers, I think, is incredible, and it really underpins the AI, the 5G, and everything we've spoken about already. I'm going to go back to Carl again. Where's Network Rail on this journey, and where do you see the real possibilities in cloud kind of enabling you to take this next step?
So we're as you've already pointed out, it's the way that the world is going, and we in Network Rail have a number of different large-scale projects and programs that are looking to take advantage of cloud-based computing. The first area would be our intelligent infrastructure program, which is looking to really push us into a predict and prevent mentality, and that is using what's called our insights platform for various different assets. That is a cloud-based technology. I think it's on the back of a Azure-based platform. So we utilizing that in order for our maintenance teams in various different depots and routes and regions, which are obviously spread across the country, to access data on their assets wherever they are on their various different devices. Secondly, our internal IT department is migrating towards more cloud-based type activities. I think thirdly as well, as an industry, not just Network Rail, but wider than that, the Rail Delivery Group and the Rail Data Council we're making a move towards cloud-based data marketplace for all railway-based data. So we're recognizing that as an industry, we need to get better at being able to share our data. And the only way we're going to be able to share our data widely with various different suppliers or SMEs, etc., is through cloud-based technologies. But I think, as you already pointed out, this is kind of really one of the things that really does sort of hook on to the artificial intelligence and the communications channels. It does sort of hold it all together, really.
No, great. I think you made a really good point there. It's going to be my next kind of question here. The kind of data marketplace, this kind of avenue to collaborate, which I think the cloud really offers, and kind of collaborate with new players as well, potentially, that you wouldn't have had a chance with originally. Where do you see Network Rail collaborating, and how do you see this opening up in the future to maybe collaborate with new entrants as well, even across different industries?
I think it's not just Network Rail. I think if you read the report that was published this time last year, wasn't it, the William Shapps Plan for Rail, which started the creation of Great British Railways. Within that was commitment number 56, which said that the Great British Railways would have an open by default attitude towards data and data sharing. And I think that's a recognition that we're now in a world where actually, as a generator of so much data, the railway industry has a lot to learn by sharing what it can and understanding insights that it doesn't yet know, and that can only be achieved through opening that data up to companies, SMEs, data scientists, rather than holding on to it. So we really need to move into that space and get people to tell us what we don't know.
I think that's great. And Andrew, with your engineering background, you must be really excited about this kind of opening up of data, kind of sharing between industries. What's your kind of view on maybe some opportunities where you can see different industries coming together?
Yeah, I think well, there's just so many possibilities just within the railway industry. As a developer of individual railway systems, I've always felt that wouldn't it be great if I could just get that bit of data that system over there has, or that bit of data from that system over there, without having to generate it myself or work around not having that data. And within a safe and secure cloud, we would be able to share safety related data. So, for example, so many different signaling systems rely on understanding where the train is, understanding its position. If we can have a single system that derives that to a high level of integrity and then shares that information with all the other systems without that level of integrity being lost, then it would just make development of these additional systems so much quicker and easier. And that's one of the things that I think we can we can look to other industries about how can we take this move towards the cloud and help the railway industry move to a situation where it can much more rapidly evolve and update and roll out new systems, because that's where we're going to see some real benefits. You know, a lot of the railway systems at the moment, they get developed, they get installed, and then they don't get touched for decades. There may be a little bit of maintenance, but generally they just don't change. If we can continuously update these systems, then we can make things much more efficient. If you look at, for example, how Tesla is doing over-the-air updates to resolve faults, to improve efficiency, to add new functionality, then it's just a completely different model. If you compare Tesla to the traditional automotive manufacturers, particularly likes of like the Japanese manufacturers like Toyota, who haven't fully embraced the move towards electric vehicles and these kind of technologies. You know, Tesla are just working in a completely different way. They're not thinking, right, okay, I'm going to have a 5-year refresh cycle on my vehicles, and so you know, forcing a driver to upgrade every few years. They're continuously refining the vehicles that they've already sold, and from a customer's perspective and from a sustainability perspective, that's so much better. Let's upgrade what we've got rather than buying new. And if we can bring the railway industry towards that kind of goal, that would be really good.
Amazing. No, really interesting. We are quickly running out of time. We're about to open it up to the floor for questions from the audience, but I want to ask one more question to both of you, quick fire question before we open it up. We've obviously spoken about AI, 5G and cloud, 3 really big topics that are important. If you had to pick one more trend or technology that really excites you, that you think will transform the rail industry, what would it be? Andrew, do you want to kick us off?
Oh, that's such a hard question, because they all just have so many possibilities. I think I would go with cloud computing. I just think that is got the potential to open up so many more different players into the market. You know, we can start getting small and medium enterprises developing railway systems that are part of the signalling system, because we can remove the barriers that that prevent those kind of organizations and individuals from getting involved, and that way we will encourage so many new ideas and concepts that that we will make a big difference.
Perfect. And Carl, over to you.
I think aligned to the cloud computing, but I think for me, the thing I'm kind of most interested in seeing how it gets deployed in the railway industry is edge computing, the ability to push everything out to the edge so that you can start to get back the validator, and appreciate Andrew's point that you don't have then all of the other data to make those linkages. But I think as an industry, we need to get to a point where we start to trust and action items off of data and information. And I think we're only going to do that if we address the volumes initially. And I think then eventually you bring in the other elements to start to try and address the challenges around volume.
No, perfect. Thank you both. Really appreciate your answer. I'm sure we could keep on talking for hours on this, because it's a really interesting point I would love to deep dive in. But I'm going to hand it back over to Virginie now to introduce the live Q&A from the audience.
Yeah, thanks a lot, Mr. for the insights and for taking us through the webinar. Very interesting, fruitful, and the impact of cross-sector fertilization of the rail sector. Before just going to the Q&A session, so we offer the possibility to our clients, prospects, or to all of us in the audience, if you want to meet us and discuss particularly about this topic inside. Of course, we will be delighted to meet you at InnoTrans, because we will be part of the InnoTrans Railway Fair in September 2022. So of course, we will be pleased to discuss further together on this very interesting and fruitful topic. So let's now just check together if we have some questions. Thank you. So regarding the question that we have in the console, in the panel, so we've got a first question regarding cybersecurity. Maybe I will let you, Andrew, Johan, and Carl to see exactly who could answer to it. But first question: is there any concerns about the cybersecurity aspect of having everything connected, and or potential interference with current infrastructure? For example, the 5G antennas interfering with certain aircraft ILC antennas recently. So which they had not allowed to the deployment of 5G antennas in certain area around airports. So what is your opinion about these concerns about the cybersecurity aspect?
Okay, I'll take that one first. So yes, cybersecurity is a concern, and there are lots of people that are focusing on that area of these kind of digital upgrades. And there is an understanding in the railway sector that the railway sector is a bit behind on cybersecurity, but there are solutions out there. There are technological solutions that will make things safe despite this interconnectedness. I think the key thing is that we make sure that we follow an approach called secure by design, which is put forward by the NCSC in the UK, in that we make sure that when we design the systems from the bottom up, that they are secure in every way. And indeed, the railway industry is developing a new cybersecurity standard that is focused on the railway industry. Previously, they've been using an industrial standard that's been pretty good at improving cybersecurity, but shortly the railway industry will have its very own cybersecurity that will focus people's minds on the kind of issues that can come up. So I think it is an issue. It is something we need to keep an eye on, but there's a number of things being done that will give us confidence that we'll solve those problems.
Thanks a lot, Andrew. Thanks a lot for this first question. Indeed, that's interesting to have this live Q&A session in order to enlarge the scope that we have already developed into this webinar. We've got other question in the panel audience. So let's see if you, Andrew, you continue, or Carl and Johan. The first one is, what are the difficulties that you foresee with respect to certifying these increasingly digital systems?
Carl, Johan, do you want to take that, or shall I?
You go for it, Andrew.
Okay, I'll take that one. So what's I think there's lots of more complexity coming into these systems, and particularly bringing in technologies like AI, where we can't formally reason about them at the moment. They will make it difficult to certify systems that rely on AI. But I think, technical problems aside, I think what will be the real challenge will be how we can find a way that the certification agencies are comfortable with, that allows us to upgrade these systems, update them far more regularly than the current multi-year cycle. As I was saying earlier, one of the big benefits that we'll get from digitization is this ability to much more rapidly change these systems. But we can only do that if we can create all the certification evidence and get it through the approvals process in a rapid fashion as well. And I think we've got some ideas around how to do that, but the whole industry needs to be ready, and we need to take the certification agencies along with us.
Great, thanks a lot, Andrew, for these insights, because that's indeed a key question about this certification regarding those increasingly digital systems. We've got all the questions into the panel console. And today, according to you, are there particular partnerships between infrastructure operators that stand out or as taking the lead in digitization?
Carl, do you want to take that one?
So Carl, don't hesitate. Otherwise, Andrew.
Okay.
We'll let you lead.
The wonders of technology. So Deutsche Bahn. There's lots of operators out there that are doing some really interesting things with respect to digitization. I know that Deutsche Bahn, ProRail, SBB, SNCF, they're all investing in digital rail to some extent or another. SNCF, for example, recently got up and running a program to roll out ETCS across all of their high-speed networks. SBB planning on rolling out ETCS to their entire network in a very short amount of time. ProRail have a digital model, effectively a digital twin of their entire network, which is really good to have that level of coverage. Deutsche Bahn are doing a lot of work looking at automation. So they're interested in moving towards grade of automation level 4. So that's a really interesting challenge. Yeah, there's lots of people, lots of the European infrastructure owners are working on this. Unfortunately, Carl's microphone has broken a little, so I don't know how that's happened, but that's why he's unable to answer us.
This is the pleasure of the live. Okay, thank you. Maybe just last question, because the timing is already over. Maybe just a last question that we just received into the console. Do you think that with advancing technology across all transport types, there is increasing risk of substitution for rail, notably that rail may be less attractive as a form of transport? Do you have this kind of insight?
That's very interesting, because I think it may go the other way, actually. I think lots of people across the transportation sector are starting to talk about something called mobility as a service. In fact, they've been talking about it for many, many years. Mobility as a service is about being able to go to a provider which may not have any infrastructure themselves, but just an app developer, a business that connects consumers to providers of transportation services. So the idea of mobility as a service, you use this kind of app to plan your entire journey, and it will take on board your desires, your expectations, but plan your entire journey for you. And this has the ability to solve what's called the last mile problem that mass transport infrastructure systems have. So for example, trains and metro systems, they don't take you from door to door, they take you from one station to another. But with mobility as a service, you'll be able to book up within one application a journey from your home to your destination, and that automatically sets up a taxi or an autonomous vehicle in the future that picks you up, takes you to the train station. Then when you arrive at your destination city, another taxi is there waiting for you to take you onward. This will take a lot of the hassle out of, or take some of the hassle out of out of travelling, and enable people to work more effectively and arrive more refreshed, having travelled the majority of the journey by train. And indeed, this kind of technology is already up and running in the west coast of America. I think when it comes to the UK, it will I think move people away from their personal vehicles and towards using trains more often.
Thanks a lot, Andrew. And first of all, thank you everyone, and notably Andrew O'Torn, Carl Butler-Garnham, and also Johan Lon. That was an absolutely very interesting session that we had today. And for sure, we had many different questions, and it wasn't possible to answer to all the ones we received. But of course, we will be pleased to answer afterwards. And of course, do not hesitate to contact us in order to go further on some key topics, in order to discuss on this very interesting critical systems issues. So really, on behalf of Capgemini Engineering, thank you for joining us today. Thank you. And of course, you will have the recording session very soon appearing in our website. Thank you so much. Have a very nice day. And thanks to our experts.